Hey everybody, welcome back to episode 66 of the video series in which we program an entire video game from scratch, from beginning to end, in the C programming language. Now, if you are a regular viewer of this channel, then you've probably noticed that I've not made a video in quite some time. And there are myriad reasons for that. I won't go into all of them, but I have been thinking about changing the format of this channel a little bit. It occurred to me that if I type everything along with you live on camera, then I'll probably never finish the game. I need time alone to work on it. We're getting to the point now where I think that you have seen how the project took off, and the stuff that I typed in, or the stuff that we worked on, side by side, together with you watching me and watching every keystroke, it was valuable, up to a point, and now I think we've reached that tipping point where, you will probably see diminishing returns from just sitting here watching me type, every keystroke, you've basically have learned enough now to where you don't need that anymore, right? So I think we're basically graduating to a different format. So the game is, of course, still being made. I'm still working on it, and I think what you're going to start seeing from me in the future are these, periodic progress updates, much like the one we're going to do today. Like, I've worked on the game a little bit off camera, and I'm going to walk you through the changes that I've made, so that you understand what's going on, and how I've updated the game since the last time I recorded a video. Of course, the GitHub repository will continue to be updated with the latest, so you can still keep up there. And basically, I'm not going to record as regularly as I used to for this video series. I'm just going to, I'll record a new episode when I have accumulated enough interesting things to talk about. And I think that sounds reasonable. Because, like I said, we've reached the point where you no longer need to watch me type every single thing in. So with that said, let's see. I want to talk about some updates since the last time. I built a new PC, as you can see here. Um, the PC that I was working on previously, even though it was doing fine, it wasn't new enough to run Windows 11. But this new processor it's like an 11,000 series. Yeah, it's like an Intel Core. I don't remember. uh, it's here. Let's run this. Core i5 11600K, and it's like 4.7 gigahertz. It has AVX 512, which is kind of interesting. I haven't played with that yet, but I'm interested to see what that does to like the thermal performance of this chip. I have a massive heatsink on this chip, so I don't think it's going to be a problem. But I believe I saw in the Intel developer handbook, that thing that's like 4,000 pages. They had some special instructions in there regarding throttling the CPU when using AVX 512, specifically because apparently AVX 512 uses so much energy that it is inefficient, I guess. I don't know. And I'm running, all right, so I'm running Windows 11. I've also upgraded the repository to Visual Studio 2022, which is technically in preview status right now. I think the release candidate slash preview 5 is out now, which I may need to upgrade to it. I don't know. So sorry if that is an inconvenience. It might be an inconvenience to you, but I mean, it's, it's free. The reason I upgraded to Visual Studio 2022 is because I was personally asked to try it out and, file feedback for things that I don't like, which, there are plenty of things about Visual Studio that I don't like, that I don't think they're ever going to fix. It's just not, I was probably the wrong person to ask, because I use Visual Studio in a way that, like I write in C, and I just, I don't know. I feel like C is not a first class citizen as far as the Visual Studio IDE is concerned. So I use Visual Studio in a way that most people don't, I think, because most people don't write C in Visual Studio. Most people are using C sharp. So I don't know. I have a couple of projects in C sharp, and I've noticed that one thing that I've noticed is they updated IntelliSense in C sharp. IntelliSense in C and C++ is still kind of hot garbage if you ask me, but in C sharp it's a relatively better experience in C sharp. But I noticed that they upgraded IntelliSense. They enhanced it such that it now can autocomplete an entire line of code instead of just trying to complete the word that you're typing on. It tries to autocomplete an entire line of code. Um, but unfortunately, one thing I noticed is that it usually guesses wrong. So you hit tab to autocomplete the whole line of code, and then you end up spending more time going back and correcting it, scrutinizing it, proofreading it. Proofreading what IntelliSense auto completed for you. You probably would have been better off and saved time just typing it out yourself. So it's a pretty meh experience. Um, they finally upgraded it to they updated the IDE to be 64-bit finally, which is nice. No complaints on that. Um, they also improved the edit and continue debugging experience. In my opinion, it's a nice improvement. I've been using it, and I can show you that later on in this video. It's really handy for this video game. For example, if you want to like move a window a little bit, you don't have to. You can just shift the position of the window using edit and continue debugging. I think they call it hot reloading now, but it's edit and continue, same stuff. You can reposition a window on the fly without having to restart the entire game, for example. Um, Also, since I built a new PC, every time I built a new PC, I try to install like the minimal amount of software on it because I don't like having a whole lot of apps on my PC that I don't regularly use. So, I installed some essential stuff like Notepad++, Visual Studio, OBS. I don't even think I installed 7-zip yet. GitHub desktop client. I'm not going to use that anymore. Instead, I have just been using the GitHub integration directly from Visual Studio, and that works just fine. So you don't need the GitHub desktop client anymore if you were ever using that. So we talked about that, upgraded to Visual Studio 2022. Now using Visual Studio integrated Git instead of the GitHub client. Okay, next on the list. So last time we worked on the draw window function, and we even accepted a pull request on the draw window function. And I kind of want to go look at that. I kind of want to go look at that. Let's see, closed, added prototype procedure, draw window. Oh yeah, so the reason is because I asked for I challenged you guys to implement a thick bordered draw window for me, and this person answered the call and thought this was pretty cool, and I accepted the pull request. And basically, as you can see, maybe you can see, separate function, and it draws the window, draws it, one pixel at a time, all this kind of stuff. And this was pretty good. This is pretty good. But then I later, kind of went back through it and I changed it again. So let's go look at it. And, I can't jump to it because Visual Studio is broken. So I'll just do draw window. Here it is. Right. So there's one thing I want to show you is how I basically, well, there's two things I want to show you that I thought are pretty interesting regarding this function. Two things that I never that I modified and never explained. First of all, is we have this interesting ternary expression in the draw window function, and it's actually in a for loop too, which I thought was kind of interesting because I don't end up using these ternary expressions in for loops very often, but it really came in handy this time. And you'll notice what it does is it's a for loop, and we need to initialize this pixel value to something, either a 1 or a 0, right? So the idea is we are going to check whether this rounded corners flag is set or not. And if it is set, that's what this question mark says. It's basically a way of saying, hey, if this is true, if this expression is true, then I want you to return 1. I want you basically to initialize this value to 1. Otherwise, set it to 0. And then we keep going until, again, the idea is if the rounded corners flag is set, then we set this value to 1. If it's not, we set it to 0. And I'll show you what the actual outcome of that is. Oh, okay, okay. So it wasn't that Visual Studio was broken. It was that I needed to click on the solution over here in my window pane, Solution Explorer over here for some reason. I don't know why. But it was like showing me all of the files on the file system, and I had to click the solution file for it to. Now all this stuff is populating correctly. We're back on track now. So I'm sorry, Visual Studio. I owe you an apology. I thought you were broken and crappy, but you actually weren't. It was my mistake. Yeah, so let's run this now and see what happens. Okay, so I wrote some unit tests here for the draw window function, and you can see I drew this series of boxes, a series of windows to test all of the different combinations of flags that you can have. So as you can see, starting from left to right, you have an opaque black box, and then you have an opaque black box with rounded corners, and then you have a clear or transparent window with a white border, and then you have an opaque window with a white border, then you have an opaque window with a white border with rounded corners, then you have a white window with a black drop shadow, so forth and so on until you get to the end. You've got basically all the flags, which is a thick bordered white window with rounded corners with a shadow. So that's sort of like my magnum opus on the draw window function, is basically all the flags combined all together. And so yeah, that was the this is basically how I worked out the rounded corners thing. It was basically just to save myself from typing a lot of excess code. I tried to repurpose the same code have it be multi-purpose instead of writing it over again for all these different flags and combination of flags that the user might want. Secondly, so the ternary expressions inside of the for loops is kind of cool. The other cool thing I wanted to show off was, so when it comes to thick borders, I thought, well, we can just draw the border, we can just draw the thick window ourselves, or we could use recursion. And so I thought that would be a neat trick, is if the user wants a thick border, then all we really need to do is draw another concentric window inside of the window we already have, right? And that will result in a window that has a 2 pixel wide thick window frame, right? So this is kind of cool. I'm calling the draw window from the draw window function. And the reason why this is okay is because this recursion is not going to be infinite. It's only going to happen once because I don't supply this flag here in this function call. So what would happen if I did, though? I think that would be kind of fun to see. Let's see what happens. Draw window thick, window flag thick, right? So now what's going to happen is, I think this is going to cause infinite recursion, and I have never tested it, so I don't know what's going to happen, but it should be entertaining. Sorry if that is too loud. There we go. Okay. All right, so it did crash, exception thrown, access violation, and now look at my call stack. So it starts at WinMain, and that's a bit hard to see. I didn't download that extension that increases the font size of these windows, so you'll just have to squint here. I can pull it out somewhere else for a second to get it away from my face. WinMain and calls render frame graphics, which calls draw character naming, which calls draw window, 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 and so forth and so on, until it looks like we finally blow our stack here. It's like infinite recursion, and it just goes on until it runs out of stack space, and then you get a nice little crash here. So let's go ahead and stop that. We're in draw window. Here we go. So we take away this flag here. There we go. All right, so that is recursion, and it's kind of cool. All right, what else did I do? Let's go back to main.c, or WinMain, I mean. No, let's go back to the top of this file. All right, talked about that. Okay, so let's go look at the rest of what I did while I was not recording. As you can see, I have updated this window with a player stats HUD over here. It includes your name. Notice how your player's name is nicely centered on the top line. And then you've got, HP, MP, GP for health, magic, money, all this kind of stuff. Watch what happens when I walk. I encounter, okay, first I'm going to have a monster encounter. So I'll talk about the monster encounter. You can see that I am drawing a window around the monster. We just created these monsters last time. I changed the size of the battle scene, the backdrop, from, it was something like 94 pixels, and now I've made it 96 pixels. And the reason I made it 96 pixels is because Um, it's a nice multiple of 8, and in our code, if you remember back when we did all of the SIMD AVX stuff, we are drawing 8 pixels at a time, right? So any image that is a nice, multiple of 8 like that is going to be more efficient to draw. Because remember, we can draw images that are not multiples of 8. But if you'll remember back to the way the code works, is that it will draw as much as it can up on the line up until it reaches to where you have less than 8 pixels remaining, and then it will draw each of those pixels individually, and it will do that over and over again for each line in the image. So it works fine, but it simply is a little more efficient and a little faster CPU cycles wise if your image is a multiple of 8. So that's why I changed that to 96 by 96. Secondly, there's a lot to unpack here. I did a lot while you weren't watching. As you'll notice, the text here, there's a lot to talk about. First of all, there's a lot of randomization in this text, and there's also an animation to this text where it basically it's kind of has that typewriter effect to it. Like, it doesn't all just appear on the screen all at once. Yeah, so let's just back out of there and go back to this. I want to talk about this player stats screen real quick. Is simply when you are standing, when the player is standing underneath it, it moves to the other side of the screen. When you move out of the way, it goes back to top left. When you go underneath it, it switches to top right. I thought that was just a nice touch. Let me see one of these battles again, just so that you can pay attention to the text, the way that it moves, and so there's 3 things to talk about here. The first line where it says a rat crosses your path. So I want to bake in some randomization here, so it'll say different things, just because it adds flavor. It adds flavor to the game, a little variety, and it's variety. So anyway, so this a rat crosses your path is random text. I have like 3 different phrases that can be mixed and matched. The second line, you are caught off guard. This is basically a random dice roll to determine who goes first, you or the monster, who attacks first. And in this instance, it would be the rat who gets to attack me first. And then the third line, it's just more flavor text. It's random flavor text. Looks like he might have rabies. Let's see one more. Another one. A rat jumps out at you. This time we're ready for battle, so we get to attack first, and then the rat gets to say something, just for flavor. And then of course you can move that on this menu. You have an attack. You could cast a spell. You can have a wait, or you can have a run. So I don't know if I'm going to keep wait. I may change wait to defend, for example. In the Final Fantasy series, this is a really successful mechanic, I think, where some monsters, you have to attack them at the right time. Like, if you attack them at the wrong time, then you either won't do damage, or the monster might actually reflect the damage back onto you, all this kind of stuff. So you might have to wait for the monster to transform into another form, or you might have to wait for the monster to come out of its shell, or that kind of stuff. So that's what that mechanic is all about. I may change the name of it from wait to something else. I may change it to defensive stance. I might have a situation where if you the monster is powering up its powerful attack, and if you don't brace yourself in this defensive stance, then the attack will do much more damage to you. So attacking isn't always the right thing to do. Um, those are just, I'm thinking out loud. Those are probably the mechanics that I'm going to develop eventually. Um, but anyway, let's take a look now back at this code to see how I did some of this stuff. And it was pretty tedious. I'm not gonna lie. But let's see, where is it? It's in battle, yeah. Okay. So as you can see, I have enhanced these monsters quite a bit to have um, all sorts of new attributes, right? So let's go to the header file. As you can see now, the monster data structure is much meatier now, right? He has, you know, base HP, of course, his picture, his sprite, the base XP that it will give you, the amount of money it will give you when you kill him, how much damage he does, and I prefixed all these with base because I think in the random monster generator function, I probably might add a random percentage to each one of these just to make the monsters a little bit different. Like, so each rat you fight will be just a tiny bit different. Um, some rats might be stronger than other rats, etc. Um, then, like sometimes maybe the monster might even run away from you. The monster could do a regular attack, or he could even cast a spell. I also thought of this mechanic where maybe the monster's behavior is modified whenever the monster is heavily damaged. So like the monster, he might have a higher chance of running away when he is heavily damaged. And there's of course a threshold for that. Like, when does the monster consider itself to be low HP? Critical chance, critical multiplier, dodge chance, armor, run success chance. Like sometimes um, when you run away from a monster, you might not always be successful. Like the monster could block your path, and vice versa. And then here we've got the emotes. I have three emotes and then a list of known spells, which I made this data structure for spells. I haven't fleshed it out yet. But for example, a monster will have a list of spells that it knows, or it might not know any spells. Like a rat is not going to be a magic caster, so he's not going to know any spells, so that's going to be an empty array. Um, anyway, so now let's go back to the C file, and here in the emotes category, or the emotes attribute, you can see that I've got three strings here. It's an array of strings. And this is for the slime. So every time you run into a slime, you will get one of these emotes at random. And since the slime doesn't talk, I mean, he has a mouth, but he doesn't talk. So these are all like not really things that he says, but they're more of just like emotes, right? And then you get to the rat, and you got the same story with the rat. And of course, none of these numbers are final. Um, I'm going to finagle all these numbers, fine tune all these numbers later, but we're nowhere near fine tuning yet at this point. So there's our monsters. And then, okay, so the next thing is these lines of text. I made these global variables. I could also have made them static variables. It doesn't really matter which they are. It works. You can make it work either way. Um, all right, so let's see. Then, of course, I made a menu, which you saw the menu during battle. Let's see, what else is interesting? Yeah, we generate the monster, and then we roll the dice. Basically, we generate a random number using this rand_s function, and then we are using modulo. We're using modular arithmetic to basically constrain the random value to within a certain range. right? And the certain range that we're constraining it to is the count of monsters, right? So this is how you roll a random value. Now, I will say that, and I think I've mentioned this before, but modular arithmetic to generate random values can definitely cause some bias. But for the purposes of a video game, I don't think it's going to be significant. I don't think it's going to be a significant amount of bias. Now, if you were creating, security software, something that needed to be truly, as random as possible and as unpredictable as possible, you really need to watch out when you use this modular arithmetic method like this, because you don't want to introduce any sort of bias that could lead to it being easier to predict, right? And then all right, so we roll again for a random value, and then we basically select a random number between 0 and 4. And we use that to basically fill in our line 1 buffer of text with either, a wild rat approaches, and of course this, depends on the name of the monster you're fighting, or it could be a blank crosses your path, or a mean looking blank lurches towards you. I mean, I just made these things up. I could change them or add more phrases at any time, but it's basically just picking one of these at random for this particular battle. And yeah, I mean, it adds a nice little sprinkle of variety. Um, and then we roll again for a random value. And this is important because if we didn't keep rolling for new random values, uh, then it would basically we wouldn't get the randomness we were hoping for, because each time you ran into a particular type of monster, you would get the exact same sayings and the exact same flavor text each time you ran into that monster. So that you got to keep getting new random values if you want to mix and match all these different texts and stuff. Um, yeah, so this is where you roll to see who goes first. You were the monster, so you're caught off guard or you're ready for battle. And there we go. And then finally, we have the third line of text, which is the um, random emote that the monster might say to you. And that's how that works. Easy peasy. When I get to draw battle, this is where I implemented these counters that basically show how much of the text do I want to show. Because remember, it has to have like a typewriter animation to it. It has to have I can't just like splat it all on the screen at once, because it looks better. It looks more polished if I have an animation to it. It looks a little bit more authentic if I do it that way. So let's see, how do I implement that? Drawing stuff on the screen, drawing windows, drawing sprites, all this kind of stuff. Here we go. So I use the local frame counter, and I say every 3 frames, right? Because every 3 frames, this expression is going to evaluate to true. Every 3 frames, I add 1 to the characters to show local variable, right? But only if it's less than the length of the string. And then once the let's see, once the length of this scratch buffer, I guess you could call it, is equal to the full thing, that's how we know that it's done animating. And once we know that the first line is done animating, then we do the exact same thing for the second line of text. And then again, once the second line of text is finished, then we know to start on the third line of text. And once the third line of text is done, then it's time to start actually fighting. So we, pop the menu and all this kind of stuff to say whether you want to fight or cast a spell or whatever. So take one last look at that. A slime crosses your path. You are ready for battle. And then, so that's how it works, just like that. And so that is all the stuff that I have done since last time. And what I'm probably going to do is finish that battle stuff. I'm going to implement the attacks. You can attack, and when the monster runs out of HP, the monster dies, and transfers some gold and experience to your character, and all this kind of stuff. I'm also going to implement probably a shaking window, because when the monster hits you, I would like for all of the HUD or GUI elements to like shake on the screen a little bit and I'll probably also have it jiggle your Xbox controller as well when you get hit. I think that'll be cool. And so yeah, those are things that I will work on, and I will probably see you guys again later after I finish all that stuff and have more stuff to talk about. I wanted to show you, or I said earlier that I would show you the edit and continue debugging, which we never really made good use of on this channel until now. So let's go ahead and show you how that works. First of all, if I go into properties, so in C/C++, in the general, on the general page, you have debug information format, program database for edit and continue. You need to make sure that that is turned on. And then let's go somewhere. So let's actually just go ahead and start our game. Right, so let's say we wanted to change the position of this player stats window, right? But we didn't want to have to restart the entire game to do it. So I'll leave the game running, and while the game is running, I will go here into Visual Studio and find, where is it? I think it's in main, I think. Draw player stats window. Alright, and I'll set a breakpoint. You can see I've got another ternary expression in here. I'm quite fond of these ternaries. They are very useful for whenever you want things to go one way or the other, depending on a certain condition. Super handy. Alright, so let's set a breakpoint right there on draw window, and you can see that my game is paused now. And let's change something. Let's see, this is like X, Y, width, height. All right, let's change the height of the window to, say, 64. And then hit continue. Oh, take away my breakpoint. Continue. Now you can see the player stats window is now smaller, right? I want to go back to here. You don't have to set a breakpoint, you can just hit pause, but if you hit pause, it'll jump you to wherever it is in the code at that time, and you'll lose your spot. So I would probably just set a breakpoint and change it back to 96. I don't really know what the difference here is between continue and hot reload. They both do the same thing. Take away your breakpoint. Go. There. You can see that the window is back. So this is going to come in very, very handy for when you want to change small things like the position of a window without having to restart the entire game. Especially for this type of game where you have progression, like the entire game. It might be like we don't get to this part of the game until like 30 hours in, right? You don't want to have to restart the game just to change some simple like line of dialogue or something, and then have to restart the game all the way from the beginning just to make sure that it took effect. Anyway, so that's edit and continue debugging. I think I'm going to go ahead and wrap it up. It's going to be a short episode. I just wanted to show you the cool stuff that I've been working on. Uh, Obviously, if you have any questions or comments, you can comment, leave your comments on the video, and I'll be happy to respond to any comments that are interesting. You can also follow me on Twitter. You can also hit like and subscribe if you liked what you saw today and you want to see more stuff like this. Um, I might be starting up a new video series soon. That's going to be different than this game. Like I said before, of course, I'm going to keep working on this game, but in terms of live coding, I think we have reached a point of diminishing returns on this project. Like this stuff is just like really it's gotten to this point where it's kind of tedious, so it's not as entertaining to watch me live code on it. So I probably will start another live coding video series that is more interesting stuff, right? Yeah, that's all I have. So thank you very much for watching, and uh, until next time, stay safe. See you guys later.